So here's a somewhat less straightforward one that I thought also gives you a good example to like compare the second derivative test and first derivative test. So the book specifically requires you in these problems to use second derivative test. So that is where we will start. So I want to find the critical points. So I look at y prime equals, oh, I have to do a product rule here, right? So this is f, this is g. I have to do f prime g plus f g prime. So f prime is 1, so I won't bother to write it. G is e to the negative x. And then plus, my f is, so I'm not going to write the plus yet because I suspect that, you know, what if fg prime comes out to be negative? Then to avoid rewriting it, right? So x is going to be x, that's f. And then the derivative g prime using the chain rule is going to be negative e to the negative x. So I'm going to put the minus out here and the e to the negative x there. And that's my g prime. All right, so that's my derivative y prime. All right, now I'm already faced with a difficulty. I have to solve this equal to 0. And again, the AP exam loves doing this, so having you solve an equation with the e to the x in it. How do I do it? Well, factor the e to the x out. This is e to the x times 1 minus x equals 0. And then be aware that e to anything is never equal to 0. Therefore, the only possible solution to this is x equals 1. All right, so that is our only critical point. The only critical point is x equals 1. Now, my problem is I don't know whether that's a max or a min or what. So what I do is second derivative test. So we'll do s dt on x equals 1. So first of all, I have to do the second derivative. So the second derivative on this one is difficult to do, kind of. All right, but here's what you can do to make it a little bit easier. So we're going to go term by term. So we do derivative e to the negative x as negative e to the negative x. And then here's the cheat. This is minus x e to the negative x, right? Well, I already did the derivative of x e to the negative x. It was this. So I'm just going to have minus what I just got for the derivative of x e to the negative x, right? And this is going to be the derivative of x e to the negative x. It's going to be e to the negative x minus x e to the negative x. So then when I simplify that down, I get negative 2 e to the negative x plus x e to the negative x. All right. So now when I go to do y double prime of 1, right? So if I want to do y double prime of 1, and I don't want to have to go, you know, negative 2 times e to the negative 1 plus 1 times e to the negative 1. You can avoid that. Watch, if I factor the y double prime and say this is x minus 2 times e to the negative x, and then I observe that e to the negative x, e to anything is always positive. E to the negative x is greater than 0. Therefore, the factor x minus 2 determines the sign of y double prime. So y of 1 is going to be negative. Right, I'm going to put 1 in there. It's going to be negative times a positive. And that's the only critical point that I have. Therefore, y has a max at 1. Okay, let's find out the y coordinate is not that hard. Put 1 in here. I have 1 times e to the negative 1. So we could call that 1 over e, right? That's what e to the negative 1. That's the max. All right. Now, here's what else I know. So, by the way, I've answered the question. I'm done. But here's what else I know. This is the only critical point. It's a max. Therefore, the max is absolute, and the function decreases everywhere else. And so if I actually look at a graph of that function, so here's where I put x e to the negative x in my Casio, just because that's what I had handy, and then draw it. That's what it looks like. Here's our max at x equals 1. It's pretty hard to see exactly that that is a max, but it is. The function drops after that. I mean, I could probably window around to make that more obvious, but I don't feel like it, so there you go. It is x equals 1. So that's second derivative test. Would it be easier to do first derivative test? I don't know. So if I did first derivative test on x equals 1, I would look at what happens when x less than 1 and x is greater than 1. Now, I already have a factored form of my derivative. So my derivative is e to the negative x, 1 minus x, and in both cases. And I still know, I'm taking advantage throughout this whole thing, that e to the negative x is greater than 0. E to the negative x is greater than 0. So that's positive, right? Then when x is less than 1, this is positive. This term is positive. When x is greater than 1, this term is negative. So here, when x is less than 1, y prime of x is positive, and here y prime of x is negative. So up here, by the way, my justification was by s dt, which I forgot to mention. Down here, we're going to say because y prime changes from positive to negative at x equals 1, y has a max at 1 over e. All right, same conclusion, two different justifications. Is one easier than the other? Not entirely. I would say in this case, the first derivative test is kind of easier because the second derivative test was kind of hard to get. So the second derivative, to get that second derivative, which it was just a little bit of a mess to get from here to here and do all this extra work, right? Whereas, since I already had the factored form of y prime, the first derivative test is actually really easy because since the e to the minus x is always positive. So I'm just like, oh, when x is less than 1, the second factor is positive. When x is greater than 1, the second factor is negative. Y prime changes positive to negative. It's a max. So I think on this one, first derivative test was easier. And what made it easier is since this problem, x e to the negative x, is not only not a polynomial, it's a product. So that means that when I go to do the second derivative, it's going to be even more of a product. So that derivative is going to get more and more complicated as I go. So because the second derivative was a little harder to get on this one, second derivative test was a little bit harder to do. But the first derivative test was easy to do. All right, so, but each of these tests is a test you have at your disposal to use when you like, and you basically, you know, in most cases, you're going to be able to choose which one you want to use. But sometimes, as in this homework, it will tell you which one to use, and then you have to use whichever one it says.